This lecture is about Quicksort, which is a recursive algorithm for sorting a set of numbers. We begin by discussing a problem faced by Cinderella. After that, we will show Quicksort and analyze the running time of Quicksort. Finally, we will look into a particular subroutine that is used by Quicksort called Partition and see how we can implement it in a space-efficient manner. Let's begin. So here is Cinderella's problem. So first of all, there will be a party going on tonight, but Cinderella's stepmother doesn't want Cinderella to go to the party. So to stop Cinderella, her stepmother prepared many bolts and nuts. So there are actually n pairs of them. So there are n bolts and then n nuts, and then exactly one nut is matching one bolt. So these n pairs of bolts and nuts are mixed together. We know that all of them are of the same shape, but they are of different sizes. So here is what Cinderella's stepmother wants Cinderella to do. So she wants her to find the largest bolt and the largest nut. Okay, so Cinderella says, I see. Now the challenge here is that we cannot compare a nut with a nut. It is because by looking at two nuts, it is rather difficult to see which one is larger. And similarly, we cannot compare a bolt with a bolt. So what can we do? Here we can actually compare a nut with a bolt because we try to put the bolt onto the nut and see if it fits. When we try, then we will have three different possible results. One is the nut may be larger. The other one is the nut is fitting exactly the bolt. And the last case is the nut is too small. So in that case, by comparing a nut with a bolt, we can know which one is relatively larger. Now we have this way to do some kind of comparison. Is it possible to solve Cinderella's problem using this method? Okay, so if you want to think, let's pause, but otherwise, let us see how Cinderella came up with an idea. So the following is Cinderella's idea. So Cinderella says, okay, so let's try to take out a particular nut. Let's call it O, yeah, because the shape looks like an O, and compare the nuts with all the bolts. But we do not need to compare until the end. As soon as we get some bolt that is larger to fit the nut, then we will stop and then get the bolt T instead. Now, along the same way, when we use this nut O to compare with the bolts, so we will, along the way, get some smaller bolts. So in that case, we know that these bolts are not going to be the largest bolt, so we are going to discard them. So at some point, we will get a bolt T, which is larger than this nut O. So we now use this T and switch to row instead. So we will now take this T and try to compare it with the nuts. So we do so until we get some nuts, let's call it O prime, that is too large to fit T. And similarly, along the way, when we discover some nuts which cannot be the largest nut, we are going to discard them. Now by doing this, we start with certain nuts, we get a larger bolt. And now we have this larger bolt, and then we get an even larger nut. So we will continue this process, switching again and again the nuts and the bolt. So eventually, we must hit the largest nut or the largest bolt. And after that, we will be able to find the corresponding, if we get the largest bolt, after that we will be able to get the corresponding largest nut. And similarly, if we get the largest nut first, we will be able to get the largest bolt. And this method actually takes theta n time. The reason is that at any step, we are either removing a bolt or removing a nut. So in that case, we cannot do this forever, and then after theta n operations, then we are going to be left with a single nut and a single bolt. So this method is very, very efficient. Okay, so Cinderella's problem is solved. So she finishes her task very quickly and obtained the largest bolt and the largest nut. But her stepmother continues to say, "Oh, no, 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 don't think this is the end. There is one more task for you." So altogether, there are actually two tasks. So what is the second one? So Cinderella's stepmother says, "Now you have to sort the bolts and sort the nuts. So I want to know which bolt is the smallest, which one is the second smallest, and so on and so forth until the largest one. And similarly, which nut is the smallest, second smallest until the largest one." So we want all the bolts and all the nuts to be sorted. Okay, Cinderella have to obey her mother because otherwise she can't go to the party. So Cinderella thinks about it. Now, in the previous method, we are able to find the largest bolt and the largest nut. So in that case, this allows us to apply selection sort. So we can get the largest bolt and the largest nut, remove it, and after that, from the remaining bolts and nuts, we get the largest bolt and largest nut of them, which is now the second largest bolt and second largest nut of all. So this is actually what selection sort is doing, continuously finding the largest one. Okay, but then finding the largest bolt and largest nut takes theta n time, and altogether there are going to be theta n squared time. But unfortunately, n here is slightly large, let's say around 100. So this method will be too time consuming for Cinderella to work on. By the time she finishes it, then probably the party will be over. So we want to get a faster method. So is it possible, or are there any better way so that we can do something that is likely to be faster? Okay, Fairy Godmother came to the rescue. So here, Fairy Godmother appeared and told Cinderella an idea. So let's see. So first of all, pick one of the nuts, any of them. So you can pick any of the nuts, and then compare this nut with all the other bolts. In this way, we are able to find out what are the bolts that are smaller than the nuts, and what are the bolts that are larger than the nuts. So this is what these two steps are doing. Pick a nut, compare all the bolts with this nut, and after that, by doing so, we will be able to get nuts that are smaller, nuts that are, these are the bolts, get bolts that are smaller, bolts that are larger, and also a bolt that is exactly fitting the nut. So this is what the first two steps is doing. Now, after these two steps, we will now focus on this bolt. What we are going to do, we use the bolt that is equal to the selected nut, and then use this bolt to compare with all the nuts. We do the same thing so that we find out which nuts are larger, which nuts are smaller. So what we did here for the next step, these two steps will be, we take this bolt, compare with all the nuts. So in that case, nuts that are smaller and nuts that are larger will be found. So we now have these two to be fitting each other. All these are the smaller bolts and smaller nuts. All these are the larger bolts and larger nuts. And now what we need to do here is, we are going to sort the left part recursively and sort the right part recursively. So here, by doing so, we actually have this one being sorted in the correct position. So let's say there are two bolts and two nuts here. So we know that this one is going to be the third smallest one. So we actually know the correct position, a correct relative order of this one among all the bolts and nuts. So this method actually tries to fix some bolts and nuts into the correct position. So by the end, so we are going to have this sorted, and have this sorted. And this method is actually quicksort. And formally, quicksort will sort a set S of numbers as follows. We first pick P, some number P from S, and then we compare P with everyone in S. By comparing P with everyone in S, we are able to separate S into two groups. We find those that are containing the smaller numbers. So all of the S small, this S small set will contain all the numbers that are smaller than P. And then the remaining, so we will also get another set called S large, which contains all the numbers larger than P. And after that, we use quicksort to sort S small. We use quicksort to sort S large. So we are going to sort them recursively. Once they are sorted, we can combine the results of this step. So we will now list the sorted of S small, followed by P, followed by the sorted results of S large, so that we will get the sorted S. And the number P that we are using in step 1 is called the pivot. So pivot is the name, so we use P to represent it. So what is a pivot? So if we see a seesaw in the playground, it's like a seesaw that we see normally in the playground, then the pivot is actually this middle point. So here we call this a pivot because we are going to use this to separate all the items or all the numbers in S into two groups, one that are smaller, one that are larger. Okay, if we go back to check this idea and compare this with Cinderella's first idea, where she uses selection sort, then we will find that for the original selection sort, we are going to compare every pair of numbers or every pair of bolts and nuts. But if we use this quicksort idea, we can avoid some comparisons. In particular, once we use the pivot to separate S into two groups, S small and S large, then all the numbers in S small will never be compared with any number in S large anymore. So in that case, we will not execute all pairs of comparisons. So a bunch of comparisons will be avoided. So in such a case, quicksort seems to be better.